Okay, hi Zach. Welcome to math lesson number 9. Don't forget that after lesson 10, there's going to be a test. So pay attention a lot to this lesson because it's definitely going to be on the test. Okay, the first thing that I'm going to do is go over the problems you missed on yesterday's homework, and you only missed 2 of them. There was one that I marked you half off because you put the answer as 20 meters, and it was an area, so it has to be 20 meters squared. So you kind of missed 2.5. But pay attention to the first part of the lesson. It goes over what you missed on your homework, and then the next part is going to be lesson 9. Okay, see you in a minute. Okay, Zach, the first thing I'm going to do is just go over what you missed on your homework on lesson 8. Okay, so on lesson 8, if you want to look at the problem, it was on the practice part, and it's practice B, and it's on page 43, and it says find the area of this figure. I actually think that you know how to do this, but what I think happened is I think that you copied it wrong onto your paper because you drew a figure onto your paper that doesn't look like this. So I'll just do this one and we'll figure out if that's what happened. So just try and follow along, okay? So let's see, it says find the area of this figure. So what I'm going to do is divide this into areas that I know how to figure out, right? So this is going to be a triangle and a rectangle, and I know that this is going to be 4, and this side is going to be 10 minus 7, because I took this 10 minus this 7, and so this is going to be 3. And then that's it. I have all the information that I need to figure out how to figure out the area of this. So first I'm going to do the area of a rectangle. And the area, and if you remember the area of a rectangle, it's the length times the width. So it's going to be 10. Oh, nope, I did that wrong. Let's erase that. Okay, so it's going to be equal to 7 times 4. And the reason is because the rectangle is this guy. So I'm not going to use that 10. I'm going to use this 7, right? Because 7 is the length of that side. And then 4 is the length of the other side. So if I do 7 times 4, I get 28. And I'm not sure what the units are on this, but you can figure that out. If it's, let's see, I'll just look really quick. Let's see, it's a B. Okay, so it's feet. So this is going to be feet squared, and that's just the area of this rectangle portion. So now I've got to do the area of this triangle. The area of the triangle is area equals 1/2 the base times the height. I just write it in a little bit different way as what they presented to you. They did base times height over 2, but I just do 1/2 of the base times the height. So it's going to be 1/2. The base is 3, and then this is a right angle. So I know that the height is 4. So that would be 1/2 of 4 is 2 times 3 is 6. So the total area is going to be 28 plus 6, 28, 29, 30, 31, 32, 33, 34. So it's going to be 34, let's see, yeah, 34 feet squared. And that's the final answer. And that is the answer in the book. That's the correct answer. You put something else, but like I said, I think it's because you copied the figure wrong. Okay, now this one you did totally miss. So it tells us the perimeter of a rectangle is 30 centimeters. So there's 2 important things here. Perimeter, so this time you're adding up the length of all the sides. Okay, so let's draw a picture of that to figure it out. Here's a rectangle. It says the length of the rectangle is 10 centimeters, so this is 10. Find the width. So it wants to figure out this. So remember, and you know what you did, you put your answer as 20 centimeters, but that is not right, because I think you did 20 plus 10 is going to be 30, but there's 4 sides of a rectangle, not just 2. So you know that this is 10, this is something, and this is something, but those 2 somethings are the same, right? So it's going to be 10 plus width, which is the same, is equal to 30. And so if I simplify that, I get 20 plus 2 times the width is equal to 30. Subtract 20 from both sides. And then I get 2 times the width is equal to 10. And then W is going to be equal to 5. Okay, and so the answer is 5 centimeters. And there is a way to check it, right? So if we go back to this original rectangle and we put a 5 right here and a 5 here, then you do 10 plus 10 plus 5 plus 5. Does that equal 30? And it does. So that should be the right answer, but let me look in the book. This was problem 7. Yep, it's 5 centimeters is the answer. Okay, so now let's start going over the lesson for the day. Okay, so we are working on lesson number 9. Welcome to lesson number 9. And if you want to follow along, it starts in your algebra book on page 43. Okay, so the first part of the lesson is going to introduce a concept of rules of multiplication of signed numbers. And it wants you to first think about it this way. The sum of 3 2's is 6, meaning 2 plus 2 plus 2 is 6. Okay, so this is the same as doing 3 times 2 is equal to 6, right? You could also say it as the sum of 2 3's is 6. So this is the same as like 3 times 2 or 2 times 3. So 2 groups of 3, that equals 6. 3 groups of 2, that is going to be equal to 6. And you can think about it the way we did with addition and kind of put it on a number line. And they kind of go over how you would do that. So if you wanted to explain 3 times 2 on a number line, how would you do it? Well, you could say 3 groups of 2, just like we did in this first problem, 3 groups of 2. If we put that on a number line, you'd start at 0, okay? And you'd say, well, there's one group of 2, there's another group of 2, and there's another group of 2. So that's 1, 2, 3 groups of 2, and you end up at 6. Okay. You could also explain 2 groups of 3, right? So again, you would start at the 0, but this time you do a group of 3, it goes there, a second group of 3, it goes there, and again, you end up at 6. Okay, so there is a couple ways to do that. The problem is once you start doing negative numbers that way, it just doesn't make sense on a number line anymore. For example, it says find the product of 2 and 3 and try to put that on a number line. And you can do it, 2 and negative 3. You can do it if you say like 2 groups of negative 3. Okay, so here I'm going to start at 0, and then I'm going to say negative 3, 1, 2, negative 3, that's one group of negative 3, 1, 2, negative 3, that's another group of negative 3, and I'm going to end up at negative 6. So 2 times negative 3 is equal to 6. But before we were able to do like the other operation, right? You could say 3 groups of 2 and 2 groups of negative 3. But if we try to do that here, what happens? Well, you have 2 groups of negative 3. How do you do negative 3 groups of 2? well, you know, a group of 2 is like 2 spaces, but you can't do -3 groups of them. -3 groups doesn't make sense. It just, you can't do it on a number line, and it just doesn't make sense because you can't do 2 groups -3 times. It just doesn't make sense that way. Anyway, so what it says is that a number line is useful for addition and subtraction and things like that. But when it comes to multiplication and division, it doesn't want you to do that. It wants you to learn rules. So there are rules for multiplication and rules for division, and those are the rules that you're going to use. So we're just going to go through them one by one, and then it sounds complicated right now, but I think you'll see that it's not that complicated. Okay, so this is going to be rule number 1. Okay, it says the product of 2 positive real numbers is a positive real number whose absolute value is the product of the absolute values of the 2 numbers. Okay, what does that mean in English? Let's say it in English. When you're multiplying 2 numbers, a positive times a positive is going to be equal to a positive. Let's do some examples, and the examples are down below. So +3 times +4 is 12. Let's see if that follows the rule. So you have 2 positive real numbers that you start with, so check, check. You end up with a product that is the answer to the product of the absolute value. So absolute value of 3 is 3, absolute value of 4, +4 is 4, 3 times 4 is 12. That's true, and it ends up being a positive number. So that rule is true. It basically just means a +2 in this one plus times a +9 is going to be equal to 18. A positive times a positive is a positive. Same down below, 4 times 5 is 20. Okay, let's do rule number 2. Okay, so this one is rule number 2. And it says the product of 2 signed real numbers that have opposite signs is going to be equal to a negative number, negative real number, whose absolute value is the product of the absolute values of the 2 numbers. Okay, again, complicated way of saying that the sign, if the signs are opposite, so you have a positive and a negative, and you multiply those together, you're going to end up with a negative. Okay? And it doesn't matter the order of those things. You could start with a negative or you could start with a positive, but if they're different, you're going to end up with a negative. So in this first example, -2 times 4, let's multiply their absolute values. 2 times 4 is 8. And what's the sign going to be? It's going to be negative. Let's do the one below. 6 times 2 is going to be 12. What's the sign? It's a negative because you have one positive, one negative. Down below, 3 times 5 is 15. A negative times a positive is a negative. Okay, let's do rule number 3. Rule number 3 says, the product of 2 negative numbers is a positive real number whose absolute value is the product of the absolute values of the 2 numbers. What does this mean in English? If you have a negative times a negative, that's going to be equal to a positive. Okay, let's see some examples. -2 times -3. Well, I know that 3 times 2 is 6. What's the sign going to be? It's going to be positive. Of course, you don't have to put a positive sign. You just assume that it's positive when there is no sign. What about -5 times -3? You get 15. What about -4 times -5? You get 20. Okay. Then the chapter goes on to talk about inverse operations. And it says this about it. If one operation will undo another operation, the 2 operations are called inverse operations. Okay? So what does that mean? Let's show you an example and I think you'll figure it out. 7 plus 3 minus 3 is just going to be what? Well, it's going to be 7. Why? Because the plus 3 here and then the minus 3 cancel out. And because they undo each other, these are inverse operations. So addition and subtraction are inverse operations because they undo each other. Okay, let's do another example. 7 times 2 divided by 2 is equal to 7. Why? Because these cancel out. And again, these undo each other. So multiplication, which is what you did on top, and division are inverse operations. So these are inverse operations and these are inverse operations. Okay. Then it goes over some rules for division. So we did the rules for multiplication when you're multiplying signed numbers. Now it's going to do the 4 rules for division of signed numbers. Okay, and I just tried to simplify them because it goes into them in a lot of detail, starting at the bottom of page 44. But let's just start with rule number 1. A positive divided by a positive is going to be equal to a positive. Okay, and this makes sense because this is how you've been doing division forever, right? So let's do the first example right here. 6 divided by 3 is 2. And it's positive. Positive divided by positive is positive. The next one, 8 divided by 2 is 4. Of course, it's a positive 4. And 12 divided by 4 is 3. So if both of those numbers on the top and the bottom are positive, your answer is going to be positive. Okay, what about if you have a negative divided by a positive? Okay, so rule number 2 says, if you have a negative real number divided by a positive real number, the quotient is going to be a negative. Okay, so a negative divided by a positive is going to be equal to a negative. That's rule number 2. Let's do some examples. Negative 6 divided by 2 is going to be equal to negative 3. Okay, next one. Negative 10 divided by 5 is going to be 2. Is it positive or negative? It's going to be negative. Okay, the next one, negative 12 divided by 3 is 4. Is it going to be positive or negative? It's going to be negative because a negative divided by a positive is a negative. That's a negative, Ghostwriter. Okay, what about a positive divided by a negative? Rule number 3 says, if a positive real number is divided by a negative real number, the quotient is a negative real number. Let's do these examples. 6 divided by negative 2 is 3. Is it positive or negative? Negative. How about 10 divided by negative 5? 2, and it's going to be negative. 12 divided by negative 3 is 4, and it's going to be negative. Okay. What about a negative divided by a negative? If you do that, you end up with a positive. Okay, so let's do these examples. Negative 6 divided by negative 3 is positive 2. Negative 8 divided by negative 2, positive 4. And I'm not writing the positive sign because it's just assumed. Negative 12 divided by negative 4 is 3. Okay, I think you got it. So basically, to summarize, in multiplication and in division, if the signs are the same, in other words, they're like signs, so you have 2 positives or 2 negatives, then the answer is going to yield a positive or negative number. I'll let you think about that. It's going to be a positive number. That's like doing a positive divided by a positive, or in multiplication, a positive times a positive. So if the signs are the same, you get a positive number for your answer. Unlike signs, so that means you have a positive paired with a negative or a negative paired with a positive. If you're multiplying or dividing those, it's going to yield a negative number. So that means a positive times a negative is a negative, or a positive divided by a negative is a negative. So this is basically the final rule that you need to commit to memory. If you don't want to memorize all of the other ones, then I would just spend a little bit of time memorizing this, because that is something you need to know. Okay, that's the end of the lesson. Okay, Zach, I hope you really enjoyed that lesson. Now you're going to do your practice problems. Okay, so let me tell you what page it's on. Okay, it starts on page 45. So it's right here where it says practice. Start with those and then do the problem sets. And it's going to go to the next page on page 46 and then do all of 46. Okay, and the next page is lesson 10, so you don't have to get into that. Just do pages 45 and 46. Okay, have fun doing your math. Bye.